The quotient rule. The quotient rule, the quotient f divided by g, so some function f divided by some function g of two differentiable functions, so again that just means you can find the derivative of these functions, f and g, is differentiable for all values of x for which g of x is not equal to 0. Moreover, the derivative of f divided by g is given by the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. So again, all of this is stating the same thing as down here. This is stating the derivative of f of x divided by g of x with respect to x. And the rule is you take the denominator function times the derivative of the numerator function minus the numerator function times the derivative of the denominator function, all of that over the denominator squared, where the denominator cannot be equal to 0, because if the denominator is equal to 0, then this whole thing would be undefined. So this is the quotient rule. We're going to use the quotient rule anytime we are trying to find the derivative of two functions that are being divided by each other, like this, written as a quotient. Okay, so and we would use this rule. So let's go through the proof. Let's go through where this comes from. So this should look very familiar. This is the definition of the derivative. Okay, this is when you are taking the derivative of f of x with respect to x. But we know here that we're taking the derivative of f of x divided by g of x. Actually, we are not going to go through this proof. So this proof is similar to the product rule, so don't worry about this proof. Let's do an example here. So here is an example of when you would use the quotient rule. Again, we're going to use the quotient rule here because this function is a function divided by a function, where f of x is equal to 5x minus 2, and g of x is equal to x squared plus 1. Again, the derivative for the quotient rule, so the derivative of two functions being divided by each other, is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. Okay, so we're going to use this rule and apply it to find the derivative of this function. So y prime equals the derivative of f of x all over g of x with respect to x. And now we're just going to use this rule here. So first, g of x, well, g of x is x squared plus 1. F prime of x, well, if we take the derivative of 5x minus 2, that's going to be 5, minus f of x, which is 5x minus 2, times the derivative of g of x, which would be 2x, and then all of this is divided by g of x squared. There's the first step. The next step, we're going to simplify this. So first of all, I'm going to distribute. I'm going to get 5x squared plus 5 minus, distribute the 2 here, I'm going to get 10x squared minus 4x all over x squared plus 1 squared. So notice here that positive 5x minus 10x, positive 5x squared minus 10x squared would be negative 5x squared. And then 5 minus negative 4x, that's going to become positive 4x plus 5 all over x squared plus 1 squared. So that's going to be y prime. So that's how you apply the quotient rule to a problem like this. Again, you want to memorize these rules. I would make a note card for every derivative rule that we've gone over, and I would just quiz yourself on it daily. Let's look at number 5. Write the equation of the tangent line of the graph y equals 3 minus 1 over x divided by x plus 5 at negative 1, 1. Okay, so first of all, the equation of the tangent line, so we know we have to find the slope of the tangent line at this point here. So first of all, let's look at this function. We got y equals 3 minus 1 over x all over x plus 5. Well, since this is a complex fraction, the first thing I'm going to do, I'm going to multiply the numerator and the denominator by x, giving me 3x minus 1 all over x squared plus 5x. Now, I'm going to say f of x equals 3x minus 1. I'm going to say g of x equals x squared plus 5x. I want to take the derivative of y, which is the derivative of f of x over g of x with respect to x. And we know this rule here is g of x times f prime of x minus f of x times g prime of x all over g of x squared. So now let's just fill this stuff in. G of x we know is x squared plus 5x. F prime of x would be 3 minus f of x, which is 3x minus 1. G prime of x, which is 2x plus 5, all over g of x squared, which would be x squared plus 5, and then we're going to square that. This would be y prime. And now I'm going to simplify the numerator. So first of all, I can take this 3, I can distribute it. I'm going to get 3x squared plus 15x minus, this is going to be 6x squared plus 15x minus 2x minus 5 all over x squared plus 5x squared. Then I can combine like terms. So 3x squared minus 6x squared would be negative 3x squared. 15x minus 15x, that cancels out, or it becomes 0. Minus negative 2x, that's going to be positive 2x. And then minus negative 5, that's going to be plus 5. All over x squared plus 5x squared. Now, we want to find the equation of the tangent line, okay? And we're given a point, -1, 1. So we know this is x, we know this is y. To find the slope of the tangent line, we would plug in -1 everywhere there is an x. Okay? So this would be +1 times -3 is -3. This would be -2. This would be 5. That's going to be 0. This would be 1 minus 5 squared. This is going to be 0. This is going to be -4 squared, 16. So this would be 0. So we know the slope is 0. So now to come up with the equation of the line, y equals mx plus b. Y is 1, slope is 0, x is -1, and b is what we're trying to find. So now we know b is equal to 1. So the equation of the line would be y equals 1. That would be the slope of the tangent line. Or that would be the equation of the tangent line.